Hey guys, here we're working through some higher GCSE 9 to 1 Maths past paper exam questions on SURDS, which I know everybody loves. You can download these questions to try yourself from the description down below. Let's do this. Hey there guys, welcome back to the channel. If this is your first time here and you're trying to get the best grade in maths you possibly can, let me help. Start now by subscribing. Okay, now just quickly before we begin, I have a whole playlist on SURDS which is linked down below. I'm also going to put my indices playlist down there too, very heavily linked. And thirdly, I have a whole playlist on exam questions which you can download, that's also in the description. Okay, first up then, write root 12 1/4 as an improper fraction. Okay, so as it stands, we can't square root 12 1/4, so let's try and turn it into an improper fraction. So 12 1/4 is 4 times 12 and 1 over 4. So that is going to give us 49 over 4. So now we want to square root 49 over 4. Which gives us 7 over 2. Okay, then part B. We want to work out the cube root of 16 as a power of 2. Okay, so 16 is 2 to the power 4. Now a cube root is a power of a third. So the cube root of 16 is the cube root of 2 to the power 4. Which is 2 to the power 4 to the power 1/3. So powers separated by a bracket, multiplied together, so finally this gives us 2 to the 4/3. Okay, next up, simplify root 80, add root 2 and 2/9. Give your answer in the form a root 5 over b, where a and b are integers. Okay, so we're going to simplify each term separately first. So root 80 now we might spot maybe 4 times 20 is 80. So we could say this then is root 4 root 20. Now that is 2 root 20. Now we can still simplify root 20. Root 20 is root 4 root 5. So this is now 2 root 4 root 5. Now root 4 is 2, so we have 2 times 2 root 5, which is 4 root 5. Okay, then for root 2 and 2 ninths, again, we need to turn 2 and 2 ninths into an improper fraction. So, root 2 and 2 ninths is equal to the square root of 9 times 2 add 2 over 9, so 20 over 9. Now that we can square root the top and bottom separately, so root 20 over root 9. Now root 20 is root 4 root 5, which is 2 root 5. And root 9 is 3. So we now have 4 root 5 add 2 root 5 over 3. So now the way to add these together is go for common denominators. So essentially we can think of 4 root 5 as 4 root 5 over 1. Now we need that 1 to be a 3. So we multiply the top and bottom by 3. So we get 12 root 5 over 3. Add 2 root 5 over 3. Which then altogether is 14 root 5 over 3. Okay, then next up we want to show that 2 root 6 over root 5 minus root 3 over root 10 can be written in the form c root d over root 10, where c and d are integers. So again, deal with each part separately. So first up, 2 root 6 over root 5. Okay, so what we don't like with this guy is the root 5 on the bottom. So we rationalise it by multiplying by root 5 on the top and on the bottom. So up on the top one we are going to have 2 root 6 root 5. And on the bottom we're just going to have 5. Now up on top, root 6 root 5 is root 30. So we have 2 root 30 over 5. Now because we know we want the final thing to have a 10 on the bottom, let's make it so that we have a 10 on the bottom here. We need to multiply the top and bottom by 2. So that's going to give us 4 root 30 over 10. Okay, then for the second bit, so root 3 over root 10. This time we're going to multiply top and bottom by root 10. So that's going to give us root 30 over 10. So then finally, we now have then 4 root 30 over 10 minus 1 root 30 over 10 so we have 3 root 30 over 10. Okay, next up, we want to show that 5 root 3 minus root 12 all squared simplifies to an integer, so a whole number. So remember, this means 5 root 3 minus 12, 5 root 3 minus root 12 times 5 root 3 minus root 12. Now, with SURD expansions, I highly recommend using a table. So, 5 root 3 minus root 12, 5 root 3 minus root 12. Okay, so it's not the nicest. So in the top left box we have 5 root 3 times 5 root 3. Now that means 5 times root 3 times 5 times root 3. So we can think of that as 5 times 5 times root 3 root 3. Five times 5 is 25, root 3 is 3, 25 times 3 is 75. Okay, then we have 5 root 3 times minus root 12. So, that's going to give us negative 5 root 3 root 12. Now, surds multiplied together, so this is minus 5 root 36. Root 36 is 6, so we have minus 5 times 6, just minus 30. So this is minus 30, and so is this guy. And then the last one, we have minus root 12 times minus root 12. So that's going to be positive, negative times a negative. So root 12 is 12. So finally, our answer then is, well, 75 add 12 is 87. And then we have minus 2 lots of 30, so minus 60. And that gives us 27. Okay, then next we are told that root 5 times root 8 add root 18 can be written in the form a root 10, where a is an integer. Find the value of a. Okay, before we expand, let's simplify root 8 and root 18. So root 8 is root 4 root 2, which is 2 root 2. Root 18 is root 9 root 2, which is 3 root 2. So, that means the question is now root 5 times 2 root 2 add 3 root 2 which is root 5 times 5 root 2 which, if we expand then, is 5 root 2 root 5, which is 5 root 10. Okay, next up, Martin did this question: rationalise the denominator of 14 over 2 add root 3. We have his workings out. His answer is wrong. Our job is to find his mistake. So, to rationalise two-term denominators, we use the difference of two squares. So the denominator was 2 add root 3, so he has correctly multiplied by 2 minus root 3. On top and bottom. So the first step is right. Up on top then, 14 times 2 is 28, 14 times minus root 3 is minus 14 root 3. So the top is right. Now, his problem is when he's expanded to add root 3 times 2 minus root 3. Let's do it ourselves. So, 2 times 2 is 4. 2 times root 3, 2 root 3. 2 times minus root 3, minus 2 root 3, and now this bit is where he's gone wrong. Minus root 3 times positive root 3 is minus 3. So, for that, he had plus 3 there. So that is his mistake. He should then have had 4 minus 3 on the bottom, so the 7 would just be a 1, so the answer would be 28 minus 14 root 3. Okay, next up, Sean did this question: rationalise the denominator of 5 over root 12. So again, Sean is wrong. Find the mistake. So, she's multiplied top and bottom by root 12, so that's right. Her problem is in her next step. She has now turned root 12 into 3 root 2. But root 12 is root 4 root 3. which is 2 root 3. So, a mistake is here. Next up, write 26 over root 2 minus 12 over root 18 add to root 50 in the form a root 2, where a is an integer. Okay, so deal with each part separately. So, first up, 26 over root 2. Multiply the top and bottom by root 2. That's going to give us 26 root 2 over 2. And that is 13 root 2. Okay. Next up, 12 over root 18. Okay, now with this one, we can simplify root 18. So this is 12 over root 9 root 2. Which is 12 over 3 root 2. Twelve over 3 cancels, so this is 4 over root 2. Now rationalise the denominator. We're going to get 4 root 2 over 2. Which finally is 2 root 2. Okay, then the third one, 2 root 50 is 2 root 25 root 2. Root 25 is 5, so we have 2 times 5 root 2. This is 10 root 2. So, altogether then, we have 13 root 2 minus 2 root 2 add 10 root 2. Which altogether is 21 root 2. Okay, next up, we want to show that root 18 add root 2 squared over root 8 minus 2 can be written in the form a times b add root 2, where a and b are integers. Right. First up, let's see if anything nice happens on top. So root 18 add root 2 squared is, well, root 18 is root 9 root 2, so 3 root 2. So we have 3 root 2 add root 2 squared, which is 4 root 2 all squared. Now 4 root 2 all squared means 4 root 2 times 4 root 2. Now, 4 times 4 is 16, root 2 times root 2 is 2, so this is 32. Okay, now on the bottom, we have root 8 minus 2. So, let's simplify root 8 minus 2, so root 8 minus 2 is root 4 root 2 minus 2, which is 2 root 2 minus 2. So now our question becomes 32 over 2 root 2 minus 2. Now, every term there has a common factor of 2, so we can divide through by 2 and get 16 over 1 root 2 minus 1. Now, we need to rationalise the denominator, so now we're going to multiply the top and bottom by root 2 add 1. So, up on top, we're going to get 16 root 2 add 16. And on the bottom, make sure you can get 2 minus 1. So, that then is just 16 root 2 add 16 over 1, which is just 16 root 2 add 16. So finally, we can write this as 16 times 1 add root 2. Final page, part A, express root 3 add root 12 in the form A root 3, where A is an integer. So we need to simplify root 12. So root 12 is root 4 root 3, which is 2 root 3. So we have root 3 add 2 root 3, which is 3 root 3. Okay then, part B is a bit of a nightmare. So we want to express 1 over root 3 to the power of 7 in the form root B over C, where B and C are integers. So, first up, let's rationalise 1 over root 3. So, times by root 3 top and bottom. And we're going to get root 3 over 3. That means then we now have root 3 over 3 to the power of 7. Now this is where we're going to convert from a surd to indices. A square root is a power of 1/2. So this is 3 to the half over 3 to the power of 7. Now, powers separated by brackets multiply together. So this is 3 to the 7 halves over 3 to the power 7. Now, what we want to do is split the power on top so that we have a whole number power and then a fraction. So 7 halves is 3.5. So by the rules of indices, we can write the top as 3 to the power 3 times 3 to the power 1/2. Remember, when you multiply base numbers with powers, you add the powers together. So this is 3 to the 3.5. And on the bottom, we still have 3 to the power 7. Now, in there, top and bottom has a common factor of 3 to the power 3. So we can cancel that and get 3 to the half over 3 to the power 4. Now this, finally, is root 3 over 3 to the power 4. 3 to the power 4 is 3 times 3 times 3 times 3, which is 81. So we have root 3 over 81. Horrible question. Okay guys, that's all the SURDS questions I have for now. I hope you found it useful. If you have, please do give us a thumbs up, get subscribed to the channel. Don't forget to check out my past paper exam questions playlist, where there's all sorts of topics covered like this. If you have any requests, let me know down below in the comments. For now, take it easy, take care.